Hey class, today we're going to be talking about the autonomic nervous system, which is going to be composed of the sympathetic and parasympathetic nervous system that we're going to talk about. Just to give you some idea or scope of where we're at, we will sort of draw a map here of where we are. So we got the nervous system, which is going to be broken down into your central nervous system, which is your brain and spinal cord, and your peripheral nervous system. It's going to be broken down into somatic and autonomic nervous systems. Somatic and autonomic, which we're going to focus on today. Autonomic. Now, your autonomic nervous system, so this is motor control, voluntary motor control. So walking, talking, and then your autonomic nervous system, which is broken down into your sympathetic nervous system, sympathetic, and parasympathetic nervous systems. Sympathetic, squeeze it in there. And then also a nervous system called your enteric nervous system, which I'm going to put in brackets here because I'm not going to talk about it all. But just so that you're aware of it, there's another part of your autonomic nervous system called the enteric nervous system, which deals with gastrointestinal movement. So, let's start by talking about the basic anatomical structure of the autonomic nervous systems. And I touched on this last time, so this first part's going to be a review. So basic anatomy of, we'll say basic organization. That's better. Of autonomic nervous system. So on the last webcast, again, I mentioned that's the somatic motor system, or nervous system, which has voluntary motor control. You're going to have one nerve, so one single axon, one single neuron that's going to move, or that's going to travel from just outside your spinal cord, or from your spinal cord, excuse me, to the muscles it innervates. It's going to be a single neuron. For the autonomic nervous system, we're going to have preganglionic neurons, and postganglionic neurons. So two neurons. And for your sympathetic nervous system, so this is going to vary between the parasympathetic and sympathetic nervous system. So I'm just going to start drawing here, and hopefully this will come together through this drawing. So we'll start with your sympathetic nervous system. What I'm drawing here is just a representative view of your spinal column. And I'll say this is top part is part of the thoracic, and this bottom part is part of the lumbar. And I'm not going to really specify where we're at here. So for the sympathetic nervous system, we're going to have these nerves coming out of the spinal cord, and we're going to have relatively short preganglionic neurons stemming from the spinal cord here. Speed up the process here. And then we're going to have, in comparison, relatively long postganglionic neurons that are going to go to the effector organs. These are going to be visceral organs that are the effector organs here. I'm not going to really, here I'm just drawing neurons, trying to go quickly here. At the end here are the synaptic terminals, where you release neurotransmitters. And right here, what we've created at our sympathetic ganglion is something called that's exactly what it is, the sympathetic ganglia, or it's also called the paravertebral ganglia, or also sympathetic trunk ganglia, which is what your book specifically specifies. So this is going to be your sympathetic trunk ganglia. So we've got short pre, and long post. So if that's the way that our sympathetic nervous system is set up, our parasympathetic nervous system is going to be the opposite of that. So we're going to have long preganglionic neurons, and these are going into arbitrary spots. I'm not pointing towards anything here, just trying to illustrate length here. Long preganglionic neurons and shorter postganglionic neurons. And these, where I specifically mentioned that the sympathetic nervous system were going to originate from your thoracic and lumbar region, these are going to originate from a division called your craniosacral region. So that's going to be in the cranial region as well as the sacral region of your spinal cord. So this is craniosacral. That would be the craniosacral division of your spinal cord. And your sympathetic is going to originate from your thoracolumbar division. Thoracolumbar. Alright. So another important thing to know is that are the neurotransmitters that are secreted at each of these junctions. So for the most part, acetylcholine is going to be the neurotransmitter that you're going to associate with the autonomic nervous system, except for at the effector organs of the sympathetic nervous system. So at the effector organs, the sympathetic nervous system is going to release norepinephrine and epinephrine. So norepinephrine and epinephrine released. And then everywhere else, we're going to have here, and here, and here. This is all going to be acetylcholine. So acetylcholine released. So as a rule, think that acetylcholine is what's released, and then as the exception to that, so 1 out of 4 situations, you're going to have norepinephrine released, and that's at the effector organs of the sympathetic nervous system. So I've covered most of what we need to cover here on this webcast. The last major thing that we're going to talk about here is going to be the adrenal medulla specifically, which is one of the effector organs in the sympathetic nervous system. So the adrenal medulla. So this is going to be the most specialized sympathetic ganglia. Most specialized sympathetic ganglia. And it's going to be comprised of modified postganglionic neurons. So running into this adrenal medulla are going to be preganglionic neurons, and then the adrenal medulla is going to be comprised of modified postganglionic neurons. And the reason they're modified is because they don't have a specific synaptic endpoint. They're not synapsing on anything. Postganglionic neurons. What they're going to do is produce large amounts of these hormones right here. So these peptides right here. And that's norepinephrine and epinephrine. So instead of acting on another organ, what these are going to do is release large amounts of norepinephrine, and specifically epinephrine, into the bloodstream when you have sympathetic stimulation into the bloodstream to work on other organs. So this is going to be a special case scenario of the sympathetic nervous system. And one thing I forgot to mention up here, which I guess there's sort of room here, the sort of monikers that you want to associate with the sympathetic nervous system versus the parasympathetic nervous system are going to be fight or flight or rest and digest. So parasympathetic is going to be rest and digest, whereas sympathetic is going to be fight or flight. So in a situation, fight or goodness. So in a situation where fight or flight, so you're either going to fight or you're going to take off, you're going to need to. You're not really worried about things like digesting food or providing blood flow to non-essential organs. You're going to be just focused on getting out of there. And with parasympathetic, so this is what's going to be active. You can think of when your book says when you're sitting down and enjoying a meal, you can think of a calm meal. Your parasympathetic nervous system is going to be most active because you don't have a need to shunt blood away from digestive organs or other non-essential organs in those situations. So that's going to complete our webcast for the evening, and I will talk to you guys again a little later on this week. Thanks. Goodbye.